Welcome back to The Explainer. Today, we're diving into a really fascinating piece of research from 2026 by statistician Abraham Itzhak-Weinberg. It's this incredibly rigorous statistical study that takes a fresh look at a topic that has captivated historians, mathematicians, and, well, the general public for literally decades: the Torah codes.
For years, people have been obsessed with a really compelling question. Could there actually be hidden messages hiding in plain sight? Like, could mathematical anomalies reveal secret information locked away in ancient texts? We're talking about the idea that the Hebrew Bible might secretly encode data about future events or historical figures, stuff completely invisible to the original authors, but suddenly readable thanks to modern computing.
Okay, so to really get this, we need to quickly review the foundational concept behind the massive 1994 claim that started this whole craze, the Equidistant Letter Sequence, or ELS. Imagine you're reading a book, but instead of reading every single letter, you skip forward by a fixed interval. Say, you only read every 10th letter or every 50th letter. The original claim was that if you do this exact thing in the book of Genesis, surprisingly meaningful words and names just sort of emerge out of nowhere.
Okay, let's dive right into this. Here's the scientific mystery arc we'll be exploring today. 1. The Bible code puzzle. 2. Taking codes to 2D. 3. The ultimate stress test. 4. The results are in. And 5. A linguistic plot twist.
Section 1. The Bible Code Puzzle. First, we need to set the stage a bit, because this idea definitely didn't just appear out of a vacuum.
The whole controversy blew up back in 1994 when a paper by Whitstone and his team claimed they'd found the names and birth dates of famous rabbis hidden in Genesis using that ELS skipping method. But by 1999, an exhaustive study by McKay comprehensively shut the claim down. They proved that the 1994 results relied way too heavily on researcher degrees of freedom. Basically, they had too much wiggle room to choose how to spell names or which specific dates to use. Once you tighten those rules, the magic completely vanished. Fast forward to 2026, and Weinberg's new study asks a wild new question. What if we extend this search but look beyond just straight lines?
Section 2. Taking codes to 2D. This brings us right to the core premise of Weinberg's modern experiment. What if, instead of just hunting for flat, one-dimensional lines of skipped letters, we start looking for two-dimensional shapes?
As you'll see here, the researchers basically built their search model around 4 specific geometric placements. They took the linear text, wrapped it around into a 2D grid, and programmed a computer to hunt for letters that land perfectly on the vertices of a single hexagram, like a Star of David, as well as concentric nested rings, an outline fill of the star, and even a growing spiral. I mean, it's an incredibly creative way to rethink how information might be hidden, right?
So how does this actually work in practice? Well, the algorithm executes a massive computational hunt across over 1 million Hebrew letters. Step 1, wrap that one-dimensional text into the two-dimensional matrix we were just looking at. Step 2, apply those geometric shapes, actively testing different grid widths, radii, and rotations to see what matches up. And then finally, Step 3, run a proximity cluster search. That's essentially just hunting for a specific group of target words clustered together in the narrowest possible window of text.
Section 3. The ultimate stress test. Now, to truly see if these geometric patterns held any water, they couldn't just search for random words.
They needed a rigorous, totally unbendable target list. So they used an independently sourced, strictly verifiable list of 10 historical Israeli prime ministers. We're talking figures like David Ben-Gurion, Ariel Sharon, and Golda Meir. For every single one, they required the first name, last name, exact Hebrew birth date, and exact Hebrew death date. By locking down these historical facts in advance, the researchers completely eliminated that wiggle room that ruined the 1994 study.
But you might be wondering, how do you actually prove if a match is statistically significant? You use what's called a permutation test. The researchers took the results found in the actual real Torah text and compared them against 15 randomly shuffled control texts. Think of it like taking the exact same letters, but just shuffling them over and over like a giant deck of cards. If the real text contains a deliberate, magical code, it should produce way more matches than the shuffled gibberish, right?
Section 4. The results are in. Now, what's really interesting about this next slide is the dramatic conclusion they reached after processing billions of possible combinations. 0. Yep, out of all the 14 to 18 letter target phrases they tested across all those complex geometries, the stars, the spirals, the outlines, there were exactly 0 exact whole phrase matches.
Even throwing massive modern computational power at millions of possible anchor points, the exact matches simply did not exist.
Okay, but what about those proximity clusters we talked about, where the words are just near each other? Check out these z-scores. This measures how far the real text deviates from the randomly shuffled text. Anything above 0 means the real text had more matches, anything below means it had fewer. Astoundingly, not a single prime minister hit a positive significant score. In fact, Ariel Sharon's score was massively negative. It dropped all the way down to negative 11.79.
And just to be absolutely 100% sure, they repeated the entire experiment. This time they used generic, thematic word pairs like peace and love, light and life, and wisdom and knowledge. They looked for those same geometric clusters. And the result? They failed just as spectacularly. The scores were overwhelmingly negative, ranging from negative 14.6 to an absolutely mind-blowing negative 95.9.
And this brilliantly illustrates another point. They ran a control test to ask, is there something mathematically special about the six-pointed Star of David? So they tested the hexagram against a four-sided polygon, a five-sided one, an eight-sided one, and just a plain old circle. The hexagon sat almost exactly at the control mean, with a z-score of just 0.02. Literally, it performed no better than a basic circle. There was absolutely no geometric magic to be found here.
Section 5, a linguistic plot twist. Because honestly, all of this builds into a really unexpected revelation. Why in the world were the scores so dramatically negative?
Why did a shuffled deck of cards constantly produce more matches than the real highly structured text? The answer is a beautiful linguistic plot twist. See, human language isn't just random noise, it's incredibly structured. Real Hebrew relies on morphological patterns, repeated root words, common prefixes, and suffixes. Because of this elegant grammar, real text actually has lower entropy. But when you shuffle a text into pure random noise, you break all those grammatical rules. You accidentally scatter common letters uniformly everywhere. So counterintuitively, pure randomness actually creates way more accidental overlapping letter sequences than the structured, beautiful rules of natural language.
Weinberg totally hits the nail on the head with this quote from the paper. Just because you have a complex, highly flexible method, like searching for words wrapping in a growing spiral or a Star of David, that doesn't magically validate a flawed premise. When you actually test it rigorously against a proper randomized baseline, the patterns just completely evaporate.
So, as we wrap up this explainer, I want to leave you with a final thought. We know the human brain is hardwired to find patterns, right? Even in pure noise. But when we combine that deep instinct with modern computing and massive data sets, our potential to see things that aren't really there only grows. So the big question is, in our daily consumption of data, how often are flexible rules and researcher degrees of freedom creating illusions of profound hidden meaning? Stay curious, stay analytical, and as always, look really closely at the baseline.